Hi everyone. If you remember last time we were talking about the router and about how we need a jig or a fence to just get us these simple shapes in cut into our material. But what happens if we need to get a more complicated shape? Well, that's when we need the fantastic CNC router. You probably know that the CNC stands for computer numerical control, which is basically using computer software to get our tool, which is this little thing here, moving around inside this safety cage. We've also got an extraction unit here, which will suck away all the dust. And we also obviously need a computer to help us with the programming and also with the control of the machine. Now, to help you view this easier, I've got a little diagram here showing what's inside this machine. So we've got the router as before, but there are no handles on it because it is connected to this gantry, which is a movable set of axes. Also at the bottom here, we've got the working aspect of the router, which is the cutting tool. Now, the great thing about a CNC router is that we have control of the up and down movement. We call this the Z axis. And this is the Z axis because we have a rotating tool, and we always label that the Z axis first. The gantry also allows us to move the router from side to side. And this axis is called the X axis. X axis, there we go. And we've got the Z axis there. And the gantry will also move from front to back. And this is what we call the Y axis. So let's just pop that in there, the Y axis there. So this machine has three different axes. The Z up would be the plus direction, and the Z down would be the minus direction. The X plus is the one going to the right, and the X minus is the one going to the left, and the front to back, going backwards would be the Y plus, and coming forward would be the Y minus. So we say here that we've got 3 degrees of freedom, which means that we've got 3 axes which can move around in 3 different ways. And to move them around into these different ways, we need then the numerical coordinates, which are going to tell us exactly where the tool is moving to. And I mean exactly, you know, to 1,000th of a millimeter. These machines are so accurate. So as an example, we could just look at the position of this tool in the diagram. To get the tool into this position, we'd need the 3 coordinates X, Y, and Z. So we could have moved 342 millimeters one way. We could have moved forward with the Y, so that would be a minus of, like, say 260. And then the Z may be coming down ready to cut your material. Maybe we've gone down minus 10 millimeters there. Now in the programming, we also need codes. So we have things like G codes, which are proprietary codes, which really means about the tool direction and the tool movement. So it's, if you're doing, say, a curve, for example, it's whether you're going to go in the clockwise direction or the anti-clockwise direction. So we have like G codes like GO2 and GO3 will determine that. We also have M codes, which are miscellaneous codes. And these do things like switch the spindle on and off. So we can get the tool cutting, switch spindle on off, that's it. And another code I seem to remember was the MO3 code, which was about tool changes. If you had an automatic tool changer, then you could determine which tool you're going to use. And I really do mean that I've forgotten, because now the process is all computerized and we don't have to write these programs anymore. So I'm just going to build up a little block diagram here to show you what happens. So let's have a look at an example. If we've made like a 3D solid model on the computer using a bit of software of our choice, we can then export that into what we call an STL file. Now that stands for a stereo lithography file. Oh, I should have used a bigger box. There we are, we got it in. And this will help us to communicate with what we call a post processor. And the post processor is the one which does all the working out of the tool program. So at the end of this, we get a full tool program which contains all of those coordinates and G and M codes that we need. And I mean, it's very clever, this post processor, because it's producing, computer programs of, plus 20,000 lines, just to even do a simple 3D model. Can you imagine trying to write 20,000 lines and not getting any errors? Oh, those were the days. Okay, let's move on. So I've got a product here, which is just a decorative panel, which is being cut on a CNC router. And you can see, you can get really lovely curve work, all this intricate detail. But it's rather 2D, isn't it? It's using the X and Y coordinates really well, but it's not really profiting from the Z coordinate. So in this next product, I hope you can see that we are not only moving in the X and Y direction, but we're really using the full use of the Z as well by moving this up and down to create this lovely face cutting. And this is something that you just can't do on a manual router. So you do really need a CNC machine to be able to get all of these 3 axes being used. Now, if that wasn't amazing enough, I've got what we call here the 4th axis. And this axis is normally bolted down on the machine like this. And if we look at the axis up here, then it's rotating here around the x-axis, and we give this a letter A for the A axis. So back in the little diagram here, we've got the router as before with the cutting tool here. I'll just highlight that. We've got here what we call a stepper motor, and this is a motor which can operate under very fine control and move very small angles. And in fact, these motors are used to move the gantry around. And on this side, we've also got what we call a tailstock. You might remember that from the wood turning lathe video, which holds and supports the other end of the material which is going to be cut. We go through the same programming system because the post processor will now include the A axis and will get this material to rotate, as well as the router moving normally from side to side in the X axis. And you only need the Y axis to get to the starting point. And as a result, you'll be able to get these profile cuts rather like you can on the wood lathe, which if you remember, that is 360 degrees of symmetry. So you can get some really complicated looking items. And even more amazing is that we can get asymmetric designs cut on this CNC machine. So what do I mean by that? Well, if you look, we've got a twist in here. Now that's completely impossible to cut these twists on a normal lathe because the machine's just spinning round and round and round and round so fast. But here we can control that spin on the A axis and get it going back and forwards in slow movements as we like, as the tool runs up the X axis. and that means that we can get these really complex shapes being produced. And I really encourage you to go on the CNC internet sites and find these 4-axis pictures of these incredibly elaborate shapes which can produce on these CNC machines. Absolutely amazing. Check it out, and check me out next time for the next video. Thanks very much. Bye.